In this video, we will go over the answer key of Friday, April 10th. And our topic today is thermodynamics. And we're going to be talking about thermodynamics for a little bit now. And thermodynamics is really the science of predicting whether something will happen or not based on chaos and heat. So we're going to be talking a lot about the term spontaneous. And a spontaneous process occurs without outside intervention. So, for example, the weight lifting off the ground is non-spontaneous because I have to put energy into it. But if I let this weight go, it will drop to the ground. That's spontaneous. A car will rust without outside interference, spontaneous. But it will not unrust, non-spontaneous. If I take salt and put it in water, it will dissolve, spontaneous. Diamonds go to graphite eventually, spontaneous. And so when we talk about something spontaneous, that doesn't tell us the speed. Salt dissolving in water super fast. Diamond going to graphite hundreds of thousands of years. Both spontaneous though. So thermodynamics and kinetics or thermodynamics and speed aren't related. And we can really determine if something is spontaneous by looking at potential energy. Basically, if the energy of the system is decreased, that's favorable and it's spontaneous. The energy of the system increases, that's unfavorable and non-spontaneous. So let's just begin by looking at the word spontaneous. So this first problem is if these events are non-spontaneous or spontaneous. So combustion of natural gas is non-spontaneous. If I have butane in a tank, that usually won't explode by itself unless I put in some outside stimuli like a fire or very high temperatures. So I have to put energy in for this gas to ignite. Bike going uphill, non-spontaneous. You have to put energy into a bike to make it go uphill. Meteor falling to Earth. Yeah, that happens all the time and nobody makes it happen, so that's spontaneous. Hot drink cooling at room temperature. Again, spontaneous. No outside intervention or energy needed. Drawing heat energy from the ocean surface to power a ship is non-spontaneous. If that was spontaneous, we would never have to use fuel again. But if I wanted to draw heat from the ocean to a ship, I need to put energy in to do that. Hydrogen gas from liquid water. Again, that is non-spontaneous. If that was a spontaneous process, anytime you're over a body of water and you lit a match, you would explode all the air around you because hydrogen is super flammable. So that is non-spontaneous. Now, the way we talk about spontaneous, the way we talk about spontaneous, we have two different terms. We have enthalpy and we have entropy. And entropy, whenever you see entropy, I want you to think of chaos. Entropy is a measure of chaos, and the universe loves chaos. The universe loves entropy. So here is a visual representation. And I just want to ask to begin with, which one has more entropy or which one has more chaos? A or B? So B does, because I have two possible conformations of my spheres compared to A. So for A, if I want my system to add up to be 20 joules, both spheres have to be at 10 joules. They have no choice. I have exactly one conformation. In B, I have two conformations. Red could be at 12, blue at 8, or blue could be at 12, red at 8. So there's more chaos, more disorder, more possibilities. All of these mean entropy. So system B has more entropy. Another way to think of entropy is imagine that you have a deck of playing cards and you throw this deck into the air. What's going to happen? Are they going to come down in perfect order? Of course not. That would be way too ordered. they're going to spread out and go all over the place. That's entropy. The universe loves entropy. So determine the sign of delta S. So S means entropy. So determine the sign. If entropy is negative, that means chaos is decreasing. It's becoming more ordered. If it's positive, that means chaos is increasing, becoming less ordered. So I take a solid and I split it into two things, and one's a gas. That's an increasing of chaos, increasing of entropy. So whenever you go from a solid to a liquid, or solid to a gas, or liquid to a gas, you're increasing entropy, because these states have more freedom of motion than a solid does. So if I take two gases and smash them together and make a liquid, I'm decreasing entropy, I'm decreasing chaos. So gases have free movement, liquids don't, so I'm increasing the chaos of the universe by changing two gases into a liquid. Take a solid and a gas, put it into a solid, decrease it again. Put two gases, make one gas, or rather I take 4 moles of gas, makes 2 moles of gas. Again, I am decreasing chaos. I can arrange these 4 gases in a room a lot more different ways than I can arrange 2 molecules of gas. So that's kind of what you're thinking of when you have gas only. Which side has the more moles? That side is more chaotic. So the left side is more chaotic than the right. So if I go from left to right, I decrease my chaos, I decrease my entropy. And that's it for today. I will see you in the next video.